Jason, welcome. Welcome to our Edge AI partner discussion.
Me?
Yeah, good to see you again. So I think the last time I saw you was in Austin, Texas at our event back in February.
Yeah.
And you're based down there?
Yeah, no, I'm literally like a half mile from the the place where it was. So I was like, I should probably go to that.
That's right. Yeah, just walk on over.
Relevant to what we do. I also saw you. You guys were at Embedded World. We saw you there as well. So
yes, Nuremberg.
Yeah.
Yes, always a big deal over there. So Atym, you're tell us more about the Atym story. What's the origin story? What's the deal here?
So I said for a long time, if it's fuzzy, I'm on it. That's one of my mini mottos. I always find myself at the front end of new tech transitions, and been in CTO roles most of my career, and have been kind of riding this notion of cloud principles extending out into the edge or edge sites over the past really 10 plus years. And I was at Dell Technologies working on IoT and edge stuff with the team there from the CTO office, and we start looking at like, hey, what does it look like when you have edge hardware out in the field and you want to manage apps? Wouldn't it be nice if it felt like the cloud? And you can manage individual containers and do continuous delivery of software and just kind of modern development. But at the time, 10 years ago, like edge stuff was like old school, on-premise apps or
bare metal,
monolithic, bare metal stuff, monolithic, IoT apps or basically firmware in the case of constrained devices. So
right.
Been doing this really for the past 10 years, kind of riding down, this continuum. And was at Dell Technologies, and then I was at a company called Zadita, who's also a member. I call like Zadita's like, I'm out of the traditional data center, but I can still run like Linux and Docker and Kubernetes and all these different technologies. I want to make it feel like the cloud and kind of IT type stuff, but I'm in the physical world, like the manufacturing floor, a retail store, whatever. After Zadita, I was kind of looking at what to do next. And, my co-founder, Steven, and I were like, really, coming to like, there's an opportunity for that next step past where like a Zadita would is playing, where it's like, I'm out of the data center, but I can't even really run Docker and Linux and containers and all that. And, but wouldn't it be nice if I could, or if it felt like it? And so, I call Atym, VMware Lite or VMware Micro, or Zadita Lite. Docker on a diet is another example that I use. But
tiny VMware,
sure. Like we are infrastructure. We enable very, very lightweight containers, like thousands of times lighter than Docker, on edge devices. And so it really is like make MCUs, like base devices, traditionally firmware, one change, you recompile the whole code base and you deploy it. It's like brute force. 80% of the developers out there don't know how to program in C or C++ for firmware.
Right.
Wouldn't it be nice if those the stacks were more like containers? So we're focused on MCU based devices with as little as 256 kilobytes of memory.
Right.
Up through CPU-based devices that have maybe about 2 gigs of memory. Above that, it's a solved problem. There's a lot of stuff like out there, but there's this spectrum of the edge that has been kind of neglected in the past.
Yeah, and so you're in that kind of middleware space. I don't know if that's the right term.
Where infrastructure is probably the right word. But we don't sell apps. We're not about that. We're not in the data path. Your data is never coming to us. We help you orchestrate containers. If you're buying our platform, like a SaaS solution, you would buy us just like you would buy AWS. But instead of managing containers on servers in some remote data center or cloud, whatever, you are managing them on fleets of devices out in the field. Or if you're an OEM buying an enterprise license, that it could be hosted on-prem, it could be hosted in your own cloud, but it could be labeled as your own company's product, like white labeled. So it's infrastructure. Think of it as kind of like AWS for really tiny devices.
Right. And how long has Atym been around?
So we were born out of some IP that Stephen and I helped shape in the like 21, 23 timeframe. So basically a couple years. We were founded in the fall of 23. So coming up on 2 years.
Yeah, pretty fresh.
Yeah.
Yeah, no, it's there's this whole I think if we go back, I mean, being in the business for a while, back in the embedded system days, right, it was all very bespoke bare metal stuff. Kind of, in those days you got things to run and you ship it and forget, flash it and forget it, kind of get it out there. And it was, it would run for 10 years until it died. And then, things got connected to the cloud, but from the IoT side, right? That was the old IoT days where it was sort of like, I have this funky thing, I'm going to connect it to a cloud, and God help us, we'll see what happens.
Coming out of the M2M days and all that.
Yes. And now it's like, we can talk more about what edge computing is, but I feel like it's really like taking a lot of those cloud principles and extending them out. Like it's almost like how do you take, and I would say the cloud world has done a pretty good job of kind of with the virtualization and management, across clouds, whether you're on AWS or Azure or Vultr or whoever, this idea of CNCF based orchestration and management of workloads is pretty standardized. And so how do you take that kind of mindset and workflow and move it out to this previously crazy, heterogeneous, funky edge stuff?
The Wild West. Yeah, I mean, I look at edge computing inherently comprehends the cloud in some sense, because if it didn't, you'd just be doing old-fashioned on-premise computing like we've done for a long time.
Right.
So even if you're running, analytics or AI models on-prem, out in the field on a device, you could comprehend the cloud in the sense that model might have been trained in the cloud. Mm-hmm. And there's a symbiotic relationship between edge and cloud and events that then get pushed back. But it doesn't mean that everything's running in one spot. It's a continuum.
Right.
But you'd like to have a similar experience across that continuum in terms of how you manage things and develop applications and all that kind of stuff. So
right. It's not edge versus cloud.
No,
it's edge plus cloud is really the solution. And we're seeing a lot of folks. And also, I think this middleware space is interesting because we have a lot of folks kind of on the make tech side, right? They create cool models and cool chips, whatever. And then there's people on the sort of the device solution side, but I call it the gap between research and reality. It's like, I make this cool thing, but how do I actually ship it and manage it in the field? And that's where a lot of the orchestration and management software needs to happen. And so what you guys are doing, and we'll talk a little bit more about how it works, but well, a little bit because we don't have that much time, but using things like WASM and other things, like how do you, since you're not using containers, how do you sort of, enable that portability across the edge? And that's a kind of a fascinating spot to be in.
It's funny, having done IoT stuff and then edge for a long time, an edge being like that intersection of digital and physical worlds, and it's very location based and whatnot. I've seen so many architecture diagrams of like data lakes and cloud hub and blah blah blah, all this different stuff, and then this tiny little box at the bottom that's like sensors and gateways and like whatever.
The real world.
Yeah, which means like you've never actually done this in the real world, because that stuff is some of the hardest part, the interconnection out in the field.
Right. And this stuff gets connected somehow. That's how it works.
So, but yeah, that's we're out in the physical world and kind of bridging things. But
yeah, it's funny, but like we were talking before we hit the record button around the terms edge AI and the edge and edge computing. And I like the idea, like edge computing it's not just local computing, there's a cloud component to it as well. And the tech world, I love the tech world because we're one of the few industries where we just make words up. Embodied AI or whatever, people just make shit up, and it's like I think it's great. So, and I was telling you about my pet peeve, which is people using the term edge AI as like a camel case, like one word, edge AI, and that's like that I get very triggered off of that. But when you think about edge and edge AI, like how do you? Because we used to be called the TinyML Foundation, and there's Tiny, and there's like all these things.
Yeah.
How do you kind of, what's your, in fact, you worked in the Linux Foundation on this.
We worked on a taxonomy there in 2020, and it was really for this reason, because there's so many loaded terms. Edge, there was people were saying, oh, it's near edge, far edge, thin edge, thick edge. There's the AI edge, the industrial edge.
Like, whatever.
Actually, no, there's one continuum from like a device up through like kind of on the factory floor, like distributed edge computing, to the on-prem data center, to a bottom of a cell tower, to a regional data center, up through right below the cloud, like at the Internet Exchange. I mean, this is a continuum, and you run things. So we looked at it instead of loaded terms like near and far, which is funny because a telco will say far edge is like the device, whereas the consumer would think the far edge is the telco tower. And so
exact opposite. Right.
It's just it lacks the context.
Right.
So we developed this taxonomy, which is what are inherent trade-offs that force choices. So instead of like some loaded term near and far, thin and thick, it is, am I in a physically secure data center or am I not? Can I run these types of tools like containers and security tools and things like that, or can I not? Am I so constrained in terms of hardware? Can I not? Can I count on 5 nines of uptime with my fiber connection to my controller, or am I probably going to lose connection because I'm out like at a mine site somewhere or a farm or whatever? So these sort of vectors define these buckets, and so the taxonomy, which you can find online, and we're even kind of talking about, can we frame some stuff within the community here with it, but like just hard trade-offs that define what considerations and what tools you would use along that continuum. So that it got really good traction when we did that, because it was just these are universal truths versus some term
right,
or ambiguous.
I like that kind of a taxonomy based on those choices. And I think we're gonna visit that. The Edge AI Foundation community is going to revisit that taxonomy too. We talked about that, and starting up a new working group here to sort of talk about these kind of commercialization issues and pulling in that taxonomy, because it kind of makes sense. And for me, it's always like you talked about secure data center. There's like a multi-tenant data center, and then there's single tenant, and then because we have folks doing like on-prem single tenant 17-inch rack-based stuff. And we would consider that edge because it's
absolutely
really constrained to it. But it is kind of a relative term. And once you get telco, let's not get telco in there, because that's a whole other thing. They just telco just comes in and ruins everything. So let's just not talk about that.
But what you run where and why and with what tools completely depends on the what part of the edge and what the use case is, what outcome you're trying to achieve. But
so tell us more about, like, for the readers that are not, this really deserves its own long tech talk, but let's talk about WASM, and like talk about how you guys are like managing portable workloads across these heterogeneous edge devices. Maybe people don't really understand that.
Yeah, so WASM, which is the short version of WebAssembly. WebAssembly is an awesome technology with a terrible name. Neither web nor assembly, as Stephen, my co-founder, would say. But it was developed a number of years ago as an alternative, or to augment really JavaScript in the browser, kind of deliver on the promise of Java from 30 years ago. The right ones run anywhere. Well, what's different is that WebAssembly, it's not a programming language like Java. It is a compile target.
Right.
So you can compile different code bases to WASM, and then that it's effectively a virtualization technology that enables you to run that code on any different architecture. So what's interesting about WASM, it's everywhere, and you probably use it every day. You don't even know about it. It's in all modern browsers when you have plugins and stuff. It's powering the Amazon Fire Stick and things like that. It's in terms of creating apps and whatnot. So it is a pervasive technology, but we made a bet on leveraging WebAssembly as an enabler for containerization on devices that can't or effectively run traditional container technologies like Docker. Right. So Atym,
and Docker, for those people, they tend to be heavier. It's kind of like an 8 gig and above.
I mean, ish. Docker on Linux, the well-known footprint like is about 256 megs of memory. So a gig at a minimum, generally, to run Docker. 2 to be comfortable, whatnot. But below that, on a box that can run Linux, it's got a CPU. It could be an ARM class or a x86 or whatever. Below that 1 gig memory range, that's the limit. The limitation is usually memory. You're doing embedded Linux. And then once you get to MCUs, it's been firmware, forever. And we joke the 90s called, they want their development tools back. I mean, it's been the same way for a long time. Yeah. But yeah, so WebAssembly, because it doesn't presuppose Linux, enables us to bring containers past what we call the Linux barrier to devices that are even powered by microcontrollers by having an RTOS-based runtime. So, what we sell is our central console. It's the hub. As I mentioned, you'd log into it like you log into AWS if you're buying the SaaS version, or it would be part of your platform if you're an OEM. We've got a built-in container repository. You could bring your own container repository. You integrate and deploy and manage secure containers out in the field. Bring your own apps, all that kind of stuff. And that's what we sell. But then we have 2 flavors of runtime. The original one is for microcontrollers. It's built with the Zephyr RTOS. It really could be any RTOS, but we chose Zephyr because it's got a lot of traction. Basically becomes the firmware on your. What's that?
No, Zephyr is pretty good target. Pretty well.
A lot of momentum. So basically, if I have a device today, it's a sensor and it's running firmware, and every single change makes me recompile that firmware. So I probably don't update it, and if I have to update it, maybe it's because of security reasons. I'm afraid of then, like, I cross my fingers because I might break it if it loses power while it's updating. But anyway, so we that runtime basically now becomes the firmware on the device, and then you deploy containers written in choice of programming language on top. And we should definitely talk about how this is really important when it comes to trying to do AI. But so that's like on a microcontroller-based device. The runtime basically becomes a firmware, and then it's all software on top of that, containers. We have a newer version that's a Linux runtime, and that runs as a Linux service. So now that's really like Docker on a diet. That's for people that are running on a gateway, a set-top box, a router, a switch, a controller, or something that has I can run Linux. I'm doing embedded Linux today. I'd like to move to Docker, but it consumes most of my memory.
Yeah,
and we would consume like a megabyte versus 256 megabytes. So you get like hundreds of megabytes back to run a more involved AI model or do something else also with. So,
and you can put AI models can be compiled into WASM as a target, right? I mean, you can go from PyTorch to Onyx to WASM.
Yeah, it's just that compile target. So an example, use case. So on MCU based devices to do AI, you guys were initially TinyML and kind of grew into broader spectrum, but TinyML is still a key component. To do that today, you got to take that code and you got to compile it into the firmware. And very likely that model code is going to continuously evolve as it's retrained and improved. So every time you do that, you got to recompile it, into the firmware. And that's challenging enough. But the other challenge is that the person that knows embedded C, that does lower level device drivers and all this kind of stuff, is not usually the person that knows machine learning and Python and Docker and Linux and all that. They're different skill sets. And so our approach, which is rooted in that sort of embedded, kind of abstract the embedded complexity of the device, and then on the top side, it feels like Docker. I mean, these containers could even live in the same repositories as Docker. It basically enables both the embedded and the AI camps to collaborate without having to fundamentally learn new stuff.
Right. Yeah, no, it's awesome. It's peanut butter and chocolate, right?
That's right. We had a customer, we have an industrial customer that, I want to put machine learning on a sensor for telemetry data.
Mm.
You got the core embedded group that knows all the lower level intricacies of the device, and then you've got this guy in this other group that knows machine learning. So we get the Atym runtime spun up on the hardware. And this case was an SD micro board with I think under a meg of memory. I think our footprint is about 128 kilobytes. Like that's 2,000 times smaller than what Docker would require.
Right.
So we get it on there, and then we get on the phone with the embedded engineer, or the machine learning engineer in this other group, and he's like, "All right, you got this new environment. What do I have to change, to do, use this newfangled stuff?" And we're like, "The target directory." Literally the exact same code that he's running on his Linux machine can just be compiled down to this tiny container on a device that has under a meg of memory.
Yeah.
And so that's that example of how it helps to bridge these different parts of the kind of different camps together.
Yeah, bringing worlds together. Well, we definitely need to do an Edge AI talk and do a deep dive and do a demo and some walkthrough and stuff. So how did you? So in terms of joining the Edge AI Foundation, I think did you first encounter us in Austin? Was that how you found us, or what was the connection?
I've been tracking TinyML Foundation for a long time. I've known you guys for a while, so. I just came in Austin because it's down the street. I mean, really, it's just a matter of convenience, really. But no, we've known you guys are doing good stuff for a long time, and a lot of the folks that we're working with are members as well, and so it's just a natural fit. Embedded, streamlining embedded, and the brute force of firmware. I call it source code soup, where everything's all compiled together. That's been a nice to have to improve for a long time. But things like cybersecurity and the Cyber Resilience Act coming up, where you have to be able to more programmatically address security and whatnot, and you'll get fined if you get if you break the regulations. That definitely is causing some concern and action.
Right.
AI fundamentally changes it. If I was a light switch running firmware like a smart light switch, and all I do is log on and turn on the light, and that's everything I'm going to do for the rest of my life. Okay, firmware, cool. Just hard code it, set it and forget it. But when I start running intelligence on that device, written by different people, including third parties, I might want to run their machine learning model, and they don't want to give me source code. They'd rather give me a binary container that protects all their IP. It completely changes the need for how you would develop embedded software. So support. I mean, we're a big believer in this whole movement and what you guys are doing, and Edge AI is one of the driving functions for what Atym is doing.
Yeah, cool. Well, Jason, it's been good to connect today. I think your colleague is going to be in Amsterdam, so I'll probably see him there.
Yep. Yeah, Brian will be there.
But we'll have to connect in person. I think I owe you a hat now that you're a full.
Yeah. That's actually really the reason.
A hat. Well, I was doing a little product placement of our new mug here.
Nice. Yeah, it was the cool hat. Was really. Let's face it. That's what did it in.
At the end of the day, it's the hat.
Yeah.
Cool. Well, it's good to connect again with you, learn a little bit about Atym. I'm sure folks are going to learn a lot more, and wishing you the best in the future.
Yep. Yeah, you too. And we look forward to collaborating in the community.
Sounds good. All right. Thanks, Jason.
Bye.